thank you very much. Sorry for the technical hiccup. This is going to come up soon. This talk is going to be about metadata routing in scikit-learn. I just didn't know how to lure you in, so I came up with a title about the use case. But the talk is going to be about a lot of things that this new feature that a bunch of us have been working on for the past couple of years enables. We're going to go through a bunch of things that don't work or didn't work and how things work now. Let's see. Is it 8,000?
If you just go, just scroll up, go back to the terminal. Scroll up and then control and then press that one.
No.
Right.
And we are there. So, a bit about me. My past academic life was machine learning in cancer diagnostics. Then I ended up doing nothing related to bioinformatics and did some machine learning consulting. Then did some algorithmic fairness privacy and somehow ended up in open source. These days I do scikit-learn, fairlearn, skops, things around scikit-learn. As I said, today we're going to talk about some scikit-learn API's limitations, and then we're going to talk about how things have been fixed in the modern versions. The very basic API that everybody loves is fit predict. You have an estimator, a simple estimator, you fit on your data, and then you predict on your test data. In scikit-learn, meta-estimators behave exactly like estimators. Meta-estimator is something that takes another estimator and some other stuff and does something on top of that other estimator. An example would be GridSearchCV, where you try to find the best hyperparameters for your model. Again, once you have your GridSearchCV, it behaves like an actual estimator. You can fit predict on it. We're going to talk a lot about metadata, and by metadata we mean things that it is a part of your data or it is about your data, but you don't necessarily want to train on it. However, you want to use that data to do something with your data. For example, you want to use some metadata to calculate some score. Imagine in fairness-related topics, you might want to use gender, zip code, race to calculate some fairness-related stuff. Or if you have a class imbalance, or for some other reason you want to use sample weights. Or if you have different groups in your data, imagine you have a bunch of data about each patient, and when you want to do cross-validate, you don't want the groups, you don't want any data leakage between your train and test for each group. The group should be either in your test data or in your training data. And you can have business-related metadata. You can have transaction, revenue per transaction, or you can have customer risk that are things about your data, and you want to pass them along. Right now, or like before metadata routing, you couldn't do that. But let's showcase some things. I'm going to generate some completely random data, completely meaningful, just to some dummy show how things work or don't work. Here I'm going to start very simple with a k-fold CV on a logistic regression, one parameter. I do GridSearchCV on that. And then I can fit, it works. How would I pass, if I had sample weights, logistic regression, I know it accepts sample weights in fit. Can I pass that from GridSearch? If I wanted to pass that, this is how it would do. I think there's an S there. And it works. Nice. What if I want to do a nested cross-validation to get a less biased version of the performance? You usually should do a nested cross-validation, which means that I'm going to put my GridSearchCV inside a cross-validate, and then I'm going to get the scores. How do I pass sample weight here? Here I would pass it as parameters, and it gets a dictionary which are the parameters that are going to be forwarded. Oh, where is, I found it. this should work. Yeah, it works. Nice. So I could forward it along. What if I had a pipeline in which I had logistic regression and I wanted to pass that along? Does this work? Let's try. First, without sample weight, just like trying that. It fails. Why does it fail? If you look at the error message, it tells you that C is not a pipeline parameter. Here, I'm trying to pass C. Make pipeline uses the class name to assign this step name, which means here I would have to do this. This is the syntax. And then this should work. Yeah, it works. How can I pass sample weight? The same way that we have to prefix the parameters, we have to prefix the sample weights too, so here it would be Does this work? It works. But hey, logistic regression is not the only step that takes sample weight. If you are using sample weight, you should pass it to every step and everything that uses it, including in this case would be the standard scalar. So we can pass it there too. So it works, and if you want to pass it here, it's kind of the same thing, except that, again, you have to pass it like as a dictionary. It is quite verbose. What happened? What did I do? But it's, I mean, it kind of works. Why not? Except that now this is a dictionary. We got it right. Yeah, nice. So as long as, like, as far as sample weight goes, things kind of work. I'm gonna show, like, even here something didn't work that we're gonna see what didn't work. But it's a pain. Any questions so far? Now let's talk about groups. You might want to pass groups to your CV objects. For example, group k-fold. Let's try that. If I want to fit, it fails because it says, well, you're trying to use a group k-fold, and that really needs the groups parameter. So you really have to pass groups. But would it work if you want to do the nested cross-validation there? The way you pass groups here to cross-validate is that it's its own parameter. And no, it doesn't work. Sorry, it just doesn't work. If I want, and the reason it doesn't work is that it's not passing along the groups to the GridSearchCV, so the inner one is not receiving it. And here, if I had just a logistic regression and I wanted to cross-validate, and here I had like the outer CV, this works. And now what if I have a custom scorer? Let's say I have a custom scorer that really needs sample weight, and what I'm doing here is f beta score with beta 2, which means recall is twice as important as precision. And then you create a scorer out of this function, and then you can pass that to your GridSearchCV. The challenges of giving a talk not with your own PC. And then if I want to fit, it doesn't work because it says I love sample weights. We didn't pass that. Well, the way we pass sample weight to the GridSearch is we pass it here. It still says I love sample weight, so what happened? GridSearchCV uses sample weights for the steps when it wants to fit, but it doesn't pass it to the scorer. You could argue that this is a bug, but we wouldn't even notice it in the old days, unless you had a custom scorer and you were like, I really need sample weight. So this is the second thing which is hard or doesn't work. So in summary, we showed that passing sample weights, it can be a pain. Groups, it doesn't work. If you want to have a scorer that takes sample weight, it also doesn't work. There is a nice, do I have a link there? There's a nice Stack Overflow post where I have an answer. The only way to fix this is that you give your scorer object the whole sample weight data, then you attach an index to, like, imagine you passing like pandas data to scikit-learn, and you attach an index to your y, and scikit-learn just happens not to remove that index, and in your scorer you would be able to take those sample weights related to your y, and then you could do like weighted scoring. A really dirty hack. But what do we do? So what was the solution that we came up with? The solution was metadata routing. We talked about what metadata are, but there are two key concepts here. One is a consumer, the other one is a router. Consumers are all the objects that know how to use the metadata. In this case, it was the scorer, or it's the logistic regression CV, or it's the group k-fold. Then there are the routers that take other objects and route this metadata to them. The way that metadata routing is enabled in scikit-learn is that the routers are responsible to route. The consumers are the ones that are responsible to tell what they need. To enable that, by default, this feature is disabled. To enable that, you just do set config enable metadata routing true. And then let's see how we would change the examples that we talked about to make things work. Here, I wanted to pass sample weight to these objects. The way that we pass them is we simply say, here I want to pass it to fit. Set fit request sample weight equal true. You could also say false if you really don't want to pass something there. And here the same, set fit request sample weight is true. You don't pass the data, you just say this is something that I need. And then here you pass with params. The benefit now is that you don't actually have to pass to each step. You just say, this is the sample weight I'm providing. Pipeline would know to which steps this needs to be forwarded. Let's run this. We got an error. Why? Oh, because this is a string. And I have 2 amps. We still get an error. Why? Love these. It says sample weight is passed but not explicitly set as requested or not for logistic regression.score. If you're not passing a custom scorer, then the score used is the scorer of the last step of the pipeline, which means here I should have said that, also said that set score request sample weight is true. This really should work. Yeah, it works. Nice. I mean, I'm biased. I mostly implemented all these features, but I really like this pattern. And then what do we do with groups? Groups are by default requested by the groups CV splitters, so you don't have to request that. And the only thing you do is that here, instead of passing it as groups, you pass it as params like the one that you did for sample weights. So here it would be groups is groups. Nice. It just splits it, it passes it to the GridSearchCV because the one inside CV also is requesting that groups. Everything just works, magic. And then what if I had my scorer that required the sample weight? How do we do here? We attach the request to the scorer. As in here, I would do set score request. And I think things should work. Things didn't work. Why do I right click? Oh, logistic regression fit also accepts sample weight, and we are passing it, and we're not saying if we want that to use it or no. Do we want it to use? We probably do. But imagine you don't for some reason. If you're passing it, you probably want to use it. But I can say sample weight. Yeah, no. Why not? It works. And then what the title promised. Imagine I want to have a score that takes something completely different into account. I want to pass a column revenue, and I want to take into account that. And the way, this is a very, very dummy score. What I'm doing is that I'm counting the number of places where my prediction and my expected value are not the same, except that I want to weight them by my revenue. So I normalize my revenue, and then I calculate, I count those, and then I normalize that by the number of observations that I have. This is my score. And then my score is like the lower the value, the better, because the best score here would be 0. Everything is the same on my predictions as what I expected. The only thing is here, I have a score request, which would be revenue is true. And then here I pass revenue. And ta-da, it works. It makes things really easy once you get used to it. So just to add everything together, this is what it would look like. You have a score that takes something into account. Then you pass the score request here. You want to pass sample weights, your steps. You pass the set fit request here. You have a group k-fold, which by default is requesting groups. And then you pass all of those as parameters to cross-validate. It knows what requires what, it forwards them, then GridSearchCV receives that, and it also knows how to forward them, and things work. By the way, the way that these methods are implemented is some Python dark magic. There was another talk I gave last year at EuroPython about how these things are dynamically generated and attached to the objects with a nice docstring and signature, which is not generic. If you're curious about how those are implemented, you can have a look at that. Thank you.